This is question number 1 in worksheet 2, gases. The diagram shows two different experiments performed at the same temperature. The curve 1 belongs to the experiment performed using 24 grams of methane, and curve number 2 shows the experiment results performed when we are using 24 grams of methane plus m grams of helium. Find the mass of helium gas found in the mixture. There are two ways we can do this question. The first method is using direct proportionalities because we know that N is directly proportional with P at constant temperature and V. We can see that the volume is constant in this experiment, and when the volume is constant in the first trial we have a pressure of P, while in the second trial after some helium gas has been added the pressure has been doubled to 2P. So if the pressure has been increased from P to 2P, the meaning is that the number of moles have been increased from N to 2N. What was the initial number of moles in the container? Let's find it out. Number of moles initial was 24 grams of methane, so it is 24 grams over the molar mass of methane, which is 16, gives us 1.5 mole of methane gas initially in the container, 1.5 mole. If the number of moles have been doubled, then at the end of the experiment, at the end of the second trial, we have 3 moles of gases in the container. 1.5 mole belongs to methane, then the other 1.5 mole should belong to helium gas which was added. So 1.5 mole of helium should give us, if the molar mass of helium is 4 grams per mole, 6 grams altogether which was added. A second way of doing this question would be to find the relation P1 V1 equals to N1R T1 for the beginning of the experiment, and then making a ratio with P2 V2 over N2R T2. Let's find out which was constant in the experiment. R's, of course, are constant. Temperature was kept constant. For the same volume, we can see that the pressure has doubled. So this is a direct relation between P1, P2, N1, and N2. If you put the numbers into the equation, you will find that number of moles of helium added again will come out to be 1.5. Let's do it quickly. P over 2P should give us 1.5 over N2, which is 3 moles at the end of the experiment, so 1.5 mole has been added. Worksheet number 2, question number 4. A certain amount of air is present in the close-end part of a manometer in diagram number 1. The height of mercury changes when the manometer is connected to gas X in diagram number 2. What is the pressure of this gas X in the second diagram? Let us start with the first diagram and let us find the pressure exerted by the gas in the close-end part of the manometer. Let's start calling it P1, the pressure exerted by this gas, is equal to the pressure of the atmosphere plus the height. So it is 75 centimeters mercury plus 18 centimeters mercury equals to 93 centimeters mercury. As we can see in the second diagram, the same gas has half the volume because it has been squeezed or compressed by the pressure exerted by gas X. So because its volume is 1/2, its pressure should have doubled. So in the second diagram, the same gas is making a 2 times 93 centimeters mercury pressure, which is 186 centimeters mercury. Now let us compare it with the pressure exerted by gas X. Which is making more pressure? Gas X is making more pressure. How much more pressure? 25 centimeters mercury. So the pressure of gas X should be equal to 186 plus 25 centimeters mercury, which is equal to 211 centimeters mercury pressure.